Welcome, my name is Craig Otto. This is Statistics for SPC, and this is the last part to the hypothesis testing, part 5. Today we're going to talk mostly about the analysis of variance and what that is used for. Okay. Basically, to get us started off, I'd like to go to a website, and the link is here. I also have it on Angel. Sorry. Jump there. Here we go. Okay. Here is a website. I like it because it gives you the step-by-step of what you need to do for analysis of variance. And basically I'll show you this, and then I'm going to give you some examples. What will happen in analysis of variance is you'll get anywhere from two sets of data all the way up to 20 sets of data is possible. I mean, usually it's between 2 to 3 sets of data. What you want to do is the first set of data, you want to enter that on your calculator under L1. So basically you're going to want to get into your list and go in and enter that information for list 1, and then the second set of data you'll enter that under list 2, and then if there's a third set you put that in list 3, and so forth. Okay, so then once you have that data entered, it's really very simple. You just go to stats, select the Anova, scroll down and select the Anova, so stats, tests, and then select Anova, which should be all the way towards the bottom. Then basically you enter your list. So if you only had 2, you just do L1, L2. But in this case they had 3, so they put in L1, L2, L3, and then you close your parentheses and you just hit enter. And what it does is it gives you actually all kinds of information, but and this information will be more valuable as you get into statistical process control, into design of experiments. Anova is a very powerful tool that we use, especially in the advanced tools class. So we'll get into more of that later, but for now we just need to know, the p-value, because you'll have like an F statistic for the F distribution, and then this p-value. So that's what we'll use to help us determine if means are equal or not. So with that, I wanted to show you how to do this on the calculator first, so that when we do this example here, it makes the most sense. Okay. Alright, so here we have a repeatability study. We have 3 different quality technicians, and they all take measurements on the same 5 parts. Okay. And our assumption is that the mean between all of their measurements is equivalent, right? Because if you're measuring something between 3 people and it measures differently, then that's a problem. That tells you that the coordinate measurement machine, the CMM, is not measuring it accurately. So the null hypothesis is that everyone's equivalent, but then the alternative is that they're not equivalent. Okay, so you can see there, and if there was 5 people, you'd have 5 different mu's out here that were equivalent for H sub O and not equivalent for the alternative. Okay, and the same as if you only had 2 people. So alright, we're doing what's called a one-way Anova. That's all we'll get into in this class, but there is something that's called like a two-way Anova, where you have other factors in there. So like instead of just looking at different operators, you might have multiple sessions of the same. So in other words, an operator would measure the same part 3 times. So that throws a whole nother dimension into it. You can look at the variation between the same operator measuring the same part, and you can look at variation between multiple operators measuring the same part. So that would be a two-way Anova. A little bit more complicated, but we're just going to stick with the one-way ANOVA for this class. Assume 95% confidence unless otherwise stated on most ANOVAs. Okay, so what you'll do is you'll go in, enter on your calculator, this operator Jeff, enter his data in L1. Okay, so you'll put 26, 32, 41, 15, and 22 into L1. Alright, and for Kim, she'll be under L2, and Bob will be under L3. Alright, so I'll give you a little bit of time. If you need to pause in order to get all this information entered, that's fine. But what we want to do is enter that data in there, and then just as I shown you on that website, you want to go to Stat, you want to scroll over to Tests, and then you want to go down to the ANOVA. Okay, so Stat, and then Tests, and then just scroll over to the ANOVA, and then it'll put ANOVA up on your screen. And then what you want to do is just enter the L1, comma, L2, comma, L3. Okay. So give you a little bit of time to do that. Now once you have that in there, you just enter those three different lists, and then you hit enter. And what will happen is it'll dump out an F statistic, and then most importantly a p-value, and that p-value in this case should be 0.226, so forth. What that basically says, again, you're assuming 95% confidence. Assume it kind of like a one-tailed test, so 0.05 is your magic number here because of 95%. So 0.05 compared to the 0.22, there is no evidence to suggest that these operators are measuring the parts differently. Okay, so we would fail to reject the null hypothesis. Okay. Next example, I'll give you some time here. Go ahead and get these different people entered in here. What we're looking at is midterm scores throughout the year, and our null hypothesis is that all the students are equivalent. The alternative being that they're not with their test scores. We're going to do a one-way ANOVA, again with 95% confidence. And once you get these entered, again you got to go into Stat, scroll over to the Test, and go to the ANOVA, which should be the last one towards the bottom. Again, hit enter, put your L1, L2, L3 in there. Alright, close your parenthesis, go ahead and hit enter, and what will happen is it'll spit out again the information, but you're looking for that p-value, and in this case the p-value was 0.001. That's very small. That's definitely less than 0.05. So you can say with confidence that you can reject the null hypothesis, that the students are performing equivalently. We reject that null hypothesis. Okay. With that is the analysis of variance. Again, it can get more complex, but we're going to keep it pretty simple at this point in the game. So just the more questions you do like it, the better you'll get. But it's pretty straightforward. I think the challenge, the biggest thing is making sure it's entered into the calculator right, and from there analyzing the p-value. So with that'll conclude our session, and also analysis of variance, and it's our last hypothesis test, so you can have a sigh of relief.